I will get started then. And I should start, I suppose, with there's a lot of opinionated content in here based on my experience with Compose systems. I genuinely encourage anyone to hop in and ask a question, because if you hold it to the end, it might kind of get lost or be hard to get back to where we were. I know that's probably more of a Yankee thing than a UK thing, but I will not be insulted or feel disrupted in any way if you guys hop in and ask questions. So with that, let's talk about dependencies and package management. This presentation started out as a request for us to possibly talk about Package Manager. And I couldn't just talk about Package Manager based on where we are as a company right now with our package management strategy. So I am Ethen Stern. I'm a CLA. I'm a managing partner at Compose Systems. Compose Systems is a small company, originally US based, and we have a Canadian member now. We're all CLAs, all 5 of us. We value agile methodologies. We use Scrum on pretty much all of our projects, although some time and materials customers do prefer more of a Kanban type ongoing software development type of an approach, but we try to see the world through the Scrum lens. And one of the things that has emerged as a sort of mutual shared value within Compose Systems over the past 3 years is that open source is one of the main ways that we reach out and try to engage and try to make a difference in the LabVIEW world. And so that's sort of a recurring theme of all of these opinions about package management. And I think for you to understand where all my strongly held or volatile opinions come from, we typically, the way things have been working lately around Compose Systems, we have 2 teams, and both of those teams has multiple developers on it. We often collaborate with our customers where they might be owning a part of the code base and we're owning another part of it, or we're mostly owning it and they're hopping in to build or to make a quick fix on the fly. And these kind of approaches lead to a lot of reuse. And also, as we've learned and grown as a company and as individuals, adding things like proper source control workflows like Git flow, following the solid design principles and building a stack of software that is dependency inverted and hierarchical, right? Small pieces at the bottom, medium pieces in the middle, and big pieces at the top. We have stressed our tooling and our processes and had to get better working as a team. We're sharing some of our open source with the framework that I maintain. I've gotten emails from people in the United States, Europe, and Asia about how to use it, and with comments and questions and feedback. So I'm certainly expanding the scope of the use of our reusable modules has been awesome, and it's also been one of those good stressors that makes you think more closely about how you're sharing, what you're sharing, and how usable your things really are. Semantic versioning, readmes, and change logs, that's part of our process now. It wasn't always. If I think back in my LabVIEW programming career 5 or 10 years, 10 years ago, I didn't even know what most of those things were. 5 years ago, I might have known, but I wasn't doing them. And then, with these processes and with the larger projects that we work on, we are unit testing our code. We're benchmarking our code. We are, when our customer can't provide hardware, we are running simulations of services on networks and basically beating the crap out of our code, even without hardware. And so all these things have really been ways that we've improved what we're doing and also stressed, like I said, stressed our tooling. All right, and it wouldn't be a Ethen Stern presentation without a somewhat cryptic reference to an old movie. There are 2 types of people in the world, those who like Neil Diamond and those who don't. You can think of vi.lib as being the source of truth and where all of the stuff goes, and rely on LabVIEW to fix all the problems of dependency management for you. Or you can see the world like the GPM users who see their project folder. And I could add to that list probably people who are used to consuming open source code through Python and other languages that have package management utilities that don't act like there is one true place to put all of the utilities or add-on code. That the project you're working on is the thing that claims those dependencies, and that's where they should go. Okay, I don't like Neil Diamond. I have done things both ways, using VIPM for a long time before I really even understood much about proper dependency management and the solid software principles, and it was fine, and it got my code running. And I've been a heavy user of GPM for about 2 years, since its creator, Derek Trepanier, who at the time was working at MGI, told me how great it was, and I bit and jumped right in. A lot of things I'm going to say can be mitigated with virtual machines. I think that virtual machines are cool and they have their place, but I do not want my daily workflow to depend on them for multiple reasons. I really value being able to give code to a customer and have them be able to run it, because it makes us look good and because it makes them not frustrated, which leads to more work. I don't like repeating the same thing over and over again when it's pointless. And I ultimately think that if you're a professional software engineer, you can kind of brush a lot of these concerns aside and just keep doing what you're doing. But at some point, you have to acknowledge that ignorance is a choice. So let's share more of my opinions. Things that professionals do. We use source control. We probably know that there are at least branching workflows so that multiple people can work together and add features without constantly stomping on each other's work by committing to main or to master. We create and consume modular code. We clearly define what parts of our software are public so that when people consume it, they know how to use it and they don't accidentally call code that was intended to be private. A semantically version. So if you're not sure what that is, you can go to semver.org and read all about it. Semantic versioning is that versioning scheme that you see everywhere, where that first number is the major version change, and when that number changes, it means it's a breaking change. It's not backwards compatible. Right? So this is another language of how we share code, and we can share it freely and openly with the freedom to make changes to it without unexpectedly breaking someone else's work. And we license our free software. If your open source is not licensed, I'm not using it. And we automate testing. Any proper solution for source code management would lead us toward these things with less rote work and with less frustration. Things that we probably don't do. And some of these are a little bit tongue-in-cheek. Some of them are unavoidable so far, where I'm editing code in LabVIEW and it just spontaneously crashes because I added an attribute to private class data. That's best I can tell, not actually my fault. But we also need to stay out of the routine of routinely blaming LabVIEW for everything that goes wrong in our code. And I know people who have built careers on this, unfortunately. Everything they write is perfect, and anytime their code crashes, it's LabVIEW's fault. Because as we all know, LabVIEW is so untrustworthy, yet we are all professional LabVIEW developers. Scratching my head right now. So we don't release untested and untraceable software, right? We don't rely on golden machines or golden anything, I guess, to make sure that our deployments continue to succeed. We don't accidentally compile the wrong code into our customer's application. We don't consume code if we don't know where it came from. If I can't find the Git repository that something open source came from, and if I can't see its block diagram, and I can't make suggestions on how to make it better or make it better myself. I don't want to touch that thing. And something we're actively trying to fix, and is sort of one of the core points of this presentation, is we don't spend hours fixing weird linking issues in LabVIEW. I wish it was true that we never did that. And what I would like to show you is that at some point in the not too distant future, maybe that's actually attainable using a workflow that we actually find to be the right one. All right, so why am I hating on vi.lib? It's not source controlled, right? You can put anything in there, and then you can build that into your application. I've always found that, so my MVA framework, the framework that I maintain as open source, when I was maintaining it as a VI package, I found that the compile was painfully slow. I found that the palette maintenance was extremely tedious, and I don't want to just be dumping on VIPM, but I did not like the workflow. I found it clumsy and frustrating. Okay, and you know, Bob's untested VI package that he either posted on LabVIEW or somehow made it onto the tools network is not equivalent to something that is unit tested and maintained by National Instruments. And it is my opinion that it should not live in the same folder and be pretending to be tested, vetted, you know, proper language level software. And as your package count grows, you're much more likely to accidentally build something with the wrong version of a driver, or get into these situations where you don't even know why you have dependencies on disk because you just had to install all of the OpenG stuff in order to use VI tester. Yeah. So again, opinion. So, you know, we have a tool that does what we need. I'm suggesting it doesn't actually, but why would we go and reinvent all this stuff when we have VI Package Manager, we have GPM? You know, you can choose your poison from the available options. Do I want one big flat thing where I just check all of my customers' code into one Git repository? You know, we were talking through this as a team as I did a dry run of this presentation, and that suggestion sparked some very colorful language from one or more of the Compose Systems teammates. I omitted it, but you know, one big package location, aka vi.lib, where we just put everything. Not a great idea. It's just what we've learned to live with, basically. And one virtual machine for every project. Well, I've had nothing but trouble with free VM solutions, and the non-free versions come with their own gotchas and caveats and maintenance of frustration. And if you're someone who heavily relies on custom glyphs or, you know, quick drop plugins and all that stuff, man, you go make a fix to one thing, and propagating that fix to all your virtual machines once you realize it's missing is such a nuisance. It's one of the things that really turns me off to heavy reliance on virtual machines for my day-to-day, you know, LabVIEW development. So my proposition is we're not reinventing anything. We're trying to take what we know about dependency management, take what we like about these different solutions, and make them into something that we are happy to live with every single day. So let's first of all clear up what a dependency is. Guessing probably everyone in the chat here is pretty comfortable with this concept, but perhaps not. When I'm talking about dependencies, and just, you know, imagine a 3-level project here where I have a top-level thing. This is my customer's application that I'm actually building into an executable at the end of the job. And that executable depends on some proprietary middle-level code. Maybe it's some code that controls the robots, or some code that does, you know, data analysis or file loading with the customer's proprietary format. And then maybe that depends on some open source code, like a by reference lookup table or some JSON string formatting, right? So there are at least three distinct tiers of code that we can talk about. We're talking about modularity. And there are some different constraints in those different levels of code. And another one of my theories, hypotheses, propositions is that those different levels demand different types of solutions right now. All right, so GPM is a package manager. This is where I'm probably going to be tempted to hop over to GPM. So I'm going to escape out of this. And let's open GPM. The GPM browser.
Just before that, Ethan, Chris Stryker says the issue with vi.lib also applies to user lib and instrument lib as well.
Yeah, anything that is a .lib folder in my central LabVIEW install directory, in my opinion, is the same exact problem. Right? I can install version 1.2 of something and build it into a customer's executable. If another customer is using the same version of LabVIEW, right, the same year of LabVIEW, LabVIEW 2020, and I meant to be using version 2. Whatever of that for some reason, I can very easily accidentally build the wrong version into the other customer's executable. If you're working, and this is a problem, of course, that is really exposed more for people who are software consultants. I work on, at any given moment, Compose Systems has between, 3 and 5 or more active customers. And the only solution that doesn't involve some tooling in the IDE is to have a virtual machine for every one of those customers. So it's like, yeah, there are so many ways you can work around it, but I don't really like any of them. So Chris, if that answers your question, or I'll leave it at that.
This is fully agreed.
Okay. Chris and I tend to agree on a lot of things, so it doesn't surprise me. Thank you for the comment. So I opened the GPM browser and it wants me to point it to the project repository that I want to operate on. So under my Git folder, which is just where I put all of my Git repositories on my local disk, I created a UKTAG project that just lives in a folder. It's an empty project. But I'm going to anchor this GPM session to that project folder. And it's asking me to create a new package name. It's inferring the LabVIEW version from the project that lives in that folder. And by default, it's going to be true, meaning I can't accidentally publish my customer's code, or in this case, my demo code, to GPM, which is a good thing. So if I wanted to install one of our packages, for example, like the Compose Systems lookup table, which happens to be a malleable by reference lookup table with in-placeness, I can click on it. You can see my README right here. You can see that I wrote it. You can see the changelog, history, and you can see that it is MIT licensed, meaning it is the most permissive open source license. And you can look for anything under the Compose Systems namespace, and you can see that we have quite a lot of stuff published to GPackage Manager as open source code. Okay, and I can pick any one of those things, sure, like this one, and I can install it by pressing this button. And GPM is going to pull that source from its Amazon bucket. It's going to put it on disk. And now it's done. Cool. So if I were to go over to a folder, forgot how to use a computer. Okay. I were to go over here into my UKTAG folder, you can see that here's my project. here's my packages folder, and under our namespace, there is now some source code that does some stuff. Okay, so that's the basic idea of GPM. Now, some of the special sauce that it adds to what I showed you is that, if I download a package like a framework that depends on multiple other packages, it's going to pull all those correct semantic versions of those packages based on what the top level thing claims. It's going to put them all on disk, and in theory, relink them all to each other because of a path change that just occurred when they got placed into my project folder. So let's hop back to the presentation for a minute. GPM really solves this bottom level problem, open source module. The most glaring reason it does not support proprietary modules is because if I publish it, it's public. There is no way right now for me to publish software that only my paying customer can get to. So that is one of the big limitations. All right, so top level application, I just showed you what this looks like in a real Windows folder. I install code, it goes into this GPM packages folder. And then that code lives, if it is namespaced, it's not required that your GPM code live under a namespace, but the creator's intention was to make namespaced code, directly from the horse's mouth, this is, to make namespaced code be more legitimate and show that it is curated and maintained by a company who has a reputation to uphold. So anyone could publish to GPM, not under a namespace, but that's the idea. So just one extra level to the folder, but when I install these two higher level packages that both depend on the lookup table, I have myself a little problem. Right? When I'm working on the MVA framework, it has a GPM packages folder of its own that has a CS namespace that has a lookup table, and it consumes that lookup table code as a dependency. However, when I go back to that previous slide, right, and I'm now merging them as dependencies of some other caller, they live next to each other. So look at the relationship of the red folder and the blue folder. LabVIEW IDE is extraordinarily bad at dealing with that path change. This is not a unique problem. If you have ever built PPLs to, solve this problem with pre-compiled code, this might sound very familiar. You have to, if you're writing a plugin architecture using PPLs and you're loading things, relative paths need to be correct when dynamic entities try to load other dynamic entities. So why don't we just use that? Pre-compiled sounds good. PPLs are a known quantity, and you could write a little tooling around it. Well, the main reason these days we don't want to use that is because malleability, which is a a la carte polymorphism that makes your code much more efficient and much more reusable, isn't pre-compilable. You can't build a PPL in current gen LabVIEW that includes malleable public methods. You can have malleable private code that's called inside your public APIs because the statically known set of options is known at the time that it's compiled into the PPL, but it really ties your hands, and it eliminates a really useful syntax improvement that was added, maybe 2018, I think. Okay, so you have to choose one, and I'm not cool with that. And then just the linking. LabVIEW search paths. This thing. When you open tools options, I find the options here to be woefully inadequate, not to mention they're independently defined on different machines. So I can get this just right so that for whatever workflow I follow, I can put my code on disk and I can coerce LabVIEW into loading the correct versions of software, possibly. But I can't make sure that Steve's computer does that. And I can have a framework that seems to me really easy to install and run. And then someone in China says, hey, I downloaded your framework and nothing works at all. What's wrong with you? Actually, people are usually much more polite, but This is not a scalable, deployable, flexible, robust solution to any problems. Compiled object cache is like the dirty secret of where LabVIEW can store its links that it thinks should exist that you don't think should exist, and then it can cross-link all your code. And then just you can do everything right. And within the past few weeks, a couple of us on the same job have somehow, having too many things on the burners at the same time, cross-linked our code and then spent an hour or more like unmessing that situation. So it's a mess. Okay, so GPM tries to solve a lot of these problems. It gives us project-based open source dependency management, meaning there's no, Ethan's open source and John's and Steve's and Paul's open source doesn't live in one folder of truth. It goes along with the project. Sorry if you can hear a dog barking. He's got good timing. It helps with package storage, discovery, and acquisition. I showed you how I can open the browser and I can just search for stuff. You can also go to gpackage.io and do a web-based search and see all of the same stuff that you're seeing here. It installs, it places those source files in the correct location on disk, right? It has a particular hierarchical structure that it enforces. It's logical, it's reasonable. It also, at least used to, would import the source files into your LabVIEW project, the top level project that it was operating underneath, and recompile those source files with that relative path change. Unfortunately, I have to put asterisks on these because as we've stress tested this over the past couple of years, there have been bugs, there have been issues, there have been things that seem like they should work that just don't. And we've gotten a little bit frustrated with the IDE especially. Right? So GPM really was our gateway to this way of thinking about dependency management. It taught us really how to properly open source with semantic versioning and readmes and licenses and all that stuff. It held us accountable. It was a way for us to share with ourselves, each other, and with people outside of our company, which kept us honest in a major way that we had never really experienced on a regular basis before. And it brought our code to other people who probably would never have seen it. So, Derek's original tagline for GPM, which you'll find on gpackage.io, is write awesome LabVIEW. And I completely believe that it did teach us how to write awesome LabVIEW, but we need something more. The way we're using this, I think our use case has outgrown the original product. This is, for better or for worse, how we feel about it. We had a package that a couple of our customers' jobs use that for some reason just can't be downloaded anymore, and we've escalated that and submitted high priority issue requests through the issue tracker. There are features that we think we just really need to continue moving on with this as our package management tool, and it feels like the thing's collecting dust, and we're not getting responses to the blocking issues, and that's a problem. We don't want to fork it because of what we've already accomplished, sort of tangentially. All right, so back to these three levels. We originally, and when I say we, I mean mostly Steve Ball, my colleague at Compose Systems, and Maciej Kolasko, another one of my colleagues at Compose Systems, have done most of our sort of internal exploration and tooling here. Steve's mostly the tooling guy, but everyone's had some input, and we've also all evolved slightly unique workflows and been able to also converge on how to deliver and share code with each other. So our original problem was our large project has multiple modules. These are way too big and way too proprietary to just be G packages. But they're not top-level applications. They might be servers and APIs and top-level applications consuming a dozen of them. And we're talking about a project that is, 5,000 VIs when it's built. We needed a solution for that middle layer because one giant repository that was reaching the Git Bitbucket limit for how large a repository can be, where we're all checking stuff into that constantly, is just a nightmare. So what Steve did was he followed a workflow that was already making sense to us, and he created a package folder called externals, external dependencies, for our top level applications. And now we have this tool that will install our APIs under externals. And notice that this fundamental problem crops up again of an IDE that thinks it knows where things should be, even though I've put them exactly where I think they should be in the hierarchy underneath my project that claims all of them. So this path shift really confuses the LabVIEW IDE when laser control and motion service both depend on a network API. When I install those submodules into that location, everything breaks, just like it did with Gpackage Manager. So Steve's written a lot of compiling, intelligent compiling code that addresses this problem. And I can show you a very quick dip into the world of Git source control, right? So we have this Beckhoff ADS. So this is a Beckhoff PLC hardware, and this is a driver, high-level driver written for that. And it is a dependency consumed by this I/O service that we're using on a job. Right. So if I want to treat these Git repositories as modules that depend on modules, let me show you what this looks like in Windows. So I have this service. It has an externals folder, which lo and behold has a couple of dependencies in it. And if I drill down here, you'll see that this got installed as a Git submodule. We'll talk more specifically about what that means and how it's different from other things. But there's a Git folder in here, right? There's also a Git folder at this top level. That's totally cool. That's a Git submodule. And so in SourceTree, my Git client of choice, we use Bitbucket. You can see that all of those files under that external are changed because when that path shift happens, LabVIEW has to recompile all those, and I have to save them for me to be able to open my top level project and not have everything be broken. So unlike with GPM, I can't call an update command, but I can just open this through my Git client, and I can discard all these changes because they are purely just relinks. Goodbye. And I can do a Git pull. And now I have all the new versions of that code installed. And if I want to redo that compile, I can open our tool, which has been a catch-all for all of our continuous integration, relinking, and source code management hacks and workflows that we need to implement. And I can hop over to, where the heck was I? IO service, and I can open my JSON file that specifies some things, and I can recompile the externals, and I can press OK, and that will go through there with a fine-tooth comb and recompile all the Git code that I just pulled, make sure that everything is in working order. Now, if that sounds clumsy to you, I wholeheartedly agree. And that's all this slide is. It's just walking you through what I just showed you. It's not hard, but it's kind of clumsy, and it's easy to get lost in there. So the submodules workflow of using our Git source code as a submodule under a project gives us this project-based dependency management where that code can come from our private Git repository. It doesn't have to come from the Amazon server that GPM uses to host open source code. It addresses package storage because, well, all of our code is already in Git. It's already stored in the cloud. We just need a way of getting it onto disk in the folder that we expect it to be in and recompiling it, which it handles with grace. And then we have added, functionality to our toolchain to allow us to do that recompile with the relative path changes. GPM did this one that's crossed out. It imports the source files into your LabVIEW project. We found that we could never agree on what the assumptions should be for what it brings in. Like, should it bring in all of the code that you just brought onto disk? What if you wanted to bring the unit tests? Should the unit tests for that module become dependencies of the calling project? Probably no, but we also don't want to tell you what you can and can't do. So, so far we haven't written any scripts or anything like that to import the source files into your calling project. So we compare these things, the G package to the submodule. Where is it hosted? G packages are hosted publicly on gpackage.io. A Git submodule is just code that's in Git that lives in your repository of choice. So you can use GitHub, GitLab, Bitbucket, or whatever. And it can be public or private. The credentialing is handled by you. So you have control over who can access it. Neither of them have a package format. There is no artifact. It's your source code and meta files like your README, changelog, and license file. In my opinion, all code should have those anyway. So there is nothing special about the package. What we're really talking about here is how do I get the source onto disk so I can use it without it being broken in LabVIEW. Git Submodule supports private packages because I can make my Git repository private. Nothing else about that process cares about whether it's public or private. As long as I'm logged in on my computer and I can get to the repo, the code shows up on my disk. Obviously, anyone can and should implement README changelog licenses and follow semantic versioning. And neither of these things magically resolve how LabVIEW sucks at relinking things when the paths change. So, a quality package, the source is visible and traceable. Yeah, it should be in Git. And if it's in Git, then I'm satisfied. Semantic versioning, meta files. If I'm consuming your open source code, I need to see an issue tracker. If I can't tell you what's wrong with it, if I find a bug, that's a problem. Has unit tests under CI. A lot of these things, right, we were first really put on the trail of these things by GPM, and they are encouraged. A lot of this stuff, like the README changelog and license, when I'm in the browser and I'm publishing my code, I can put my name, my email address, my personal or company URL, and then I can put the URL to the issue tracker, to the Git repository, and all that stuff. So it is a beautiful thing. It makes all these things really transparent and easy to find. Just like when I'm browsing and I click here, you can see all this information. Go to our Bitbucket lookup table page. Right? So that's cool and super useful. There have been I've been involved in several conversations about how do I know something's high quality. This is how. So is it under CI? And then this last thing has unit tests, right? So you can do everything right, and you can put it in, again, sorry, Jim, not to beat on VIPM, but you can put it in a VI package, and you can publish it through the tools network, certified by NI, and I can install it and use it. But I can't, like with a single click, as far as I know, jump right to your unit tests and run them. Or have the option of having those unit tests on disk, but not imported into my project, right? So like, as a sign of trust, it's nice to be able to see the test coverage. All right, and as a quick segue, I know I'm pretty much out of time. What is a quality project? Right, it's in Git, it's modular, but for the top level project, all of these workflows, like basically none of them are acceptable. If I'm giving my customer code and he finds the tiniest of bugs and he wants to open that code, fix that tiny bug, and rebuild an executable, I want him to be able to pull and build the code. So, that process can't involve saying, oh, just install this compose systems tool and run this and make sure you relink, and then not acceptable. So The next thing, Steve's latest reveal to us has been this Subtrees workflow, which he started adding to our internal tooling, where at this level, at the top level, you want to pull and run. I want to be able to go to Git, get the code. It is on disk, already compiled and linked correctly, and I can just press the run button or build the exe. But then for these other levels, there's no difference. The code is hosted somewhere. I want to be able to get it. I want to follow some kind of reasonable organization underneath my project folder. And when I open it after running my script, I want it to run. Right? So what's the difference between a Git subtree and a submodule? Our team's preference is to use, so far, subtrees only for top-level applications, things that we are going to build into executables and deploy. So in a subtree, these widgets, these external dependencies, are checked into the Git repository of the top-level application. And if I, for some reason, want to make a fix to widget A that doesn't get pushed back into its original Git repository, I can make that change, check it into source control, and then when the customer pulls that, they're going to have all the changes, again, correctly linked. They can just open that code and run it. Whereas as submodules, if I were to make a change here and check that into Git, it would go back into the original widget A repository, meaning when someone pulls widget A to work on it independently, it's going to have bad links because it thinks it's linked to my top-level application. So those are two distinct cases, and they have uses. The top-level one is the one where we really need the utmost simplicity. So I promise I'm coming to the end. Where is it hosted? Same thing. These are just two different ways of using Git. Nothing about them is different, except I have this ability when I'm using a subtree to sort of diverge from the original module that it was source controlled if I want to. And also because I have to, because if I want to be able to pull that top level project and have all the dependency hierarchy come to me in that one pull with all the correct path links, I need to check it in with those links being correct. Okay. So if I wanted to use a subtree and my teammate did his job correctly, I should be able to pull it, open it, and nothing's broken. And if I'm using submodules, in a perfect world, we'd have some kind of script to just pull all of them. We'd run our recompile, which maybe would be an automated part of the script. And as soon as that was done, I would also be able to open my code and it would all be unbroken and working. So subtrees are cool. They're kind of the latest thing. They are the latest thing that we've added to our workflow to solve some problems. It behaves like it's part of the calling top-level code. Customers, co-developers jumping right in without me saying, oh, shoot, let me just upload that 20 gigabyte VM to Google Drive, and then you can pull it, you can download it, and 3 hours later or 2 days later, you can run my machine and see the problem I'm seeing. So in summary, I don't think a package manager should ever install code of unknown provenance. Like I should be able to know where the Git repo is. I should know where the unit tests are if I want to run them and look at them and see why this crappy code is actually passing. It shouldn't leave anything broken. It shouldn't cross-link, all this stuff. And in my sort of purist opinion, I don't think a package manager should ever encourage my project to load anything outside of my project's folder, unless it's something that LabVIEW installed into vi.lib. So if you, like me, believe in unicorns and you think that we can have this perfect tool that installs all my source, relinks it, wouldn't we still have to reinvent the wheel and make our code shareable and accessible? Because how are you going to know what Compose Systems code is and where you can find it? Well, our friend Chris Cellino, has created gcentral.org, and right now it's a place you can go and you can find our G packages, you can find everyone's VI packages, and you can find even other things that are hosted on Lava, right? This process of centrally finding what you're looking for doesn't rely on there being an artifact that is a proprietary file format. everything we're talking about could be found directly through gcentral, because all you'd need is a tool and know where to find our Git URL, and you'd be able to find our code. So, you know, I see other people in this space doing complementary work that is paving the way for a better way of sharing and interacting. So, you know, take your pick. We are actively working on internal tooling to make this better. I don't think any of us are comfortable with saying, you know, we've solved it all and it's ready to use, until I can say, download this and run it, and all the code's going to be exactly where it should be and it's going to work. And I can tell you that with 100% certainty. I don't think we have an open source tool to share and advertise, but we are actively working on making that tool better every single day, because none of us like linking troubles, and none of us like being made to look stupid in front of our customers because our code won't run, because LabVIEW cross-linked it to some other repository because we forgot to clear the compiled object cache. So with that, I will give it a rest and address any questions or comments.
There are a couple on the chat. I don't know if you can see them.
Okay, let me see.
One from Chris. It seems to act like you're not separating compiled code. Did I miss something he's asking?
Was the question about separating compiled code?
Yeah, so he's saying whether you're separating compiled code and why is it?
Yeah, so I think he's talking about this issue in LabVIEW, right? So I can choose to, on a VI, I think this is default settable in here. If anyone wants to make me not look stupid, feel free to just shout out where this is. But right on a V. Go ahead.
I believe it's under environment.
Here you go, Chris. Yeah, so by default, separate compiled code from new files. That's all well and good, but when I load my project into memory, right, LabVIEW compiles all these things, including their path relationships to each other, into this mysterious object cache. And I have an uncountable number of times done all my stuff, passed all my unit tests, everything is hunky-dory. There's nothing weird in my auto-populating dependencies folder. Checked my code into Bitbucket and, you know, patted myself on the back for a good day's work. The next day, for some reason, cleared compiled object cache, opened that code that was perfect, passed all the tests, and I had done everything right. And all of a sudden, LabVIEW is confused about where some of that code lives on disk. Right? So there's still some kind of mysterious garbage living in compiled object cache that checking this box does not address. Checking this box for us saves us from the unnecessary burden of stomping on source code commits with changes that are just recompile changes. It seems to reduce that problem, but it does not address any of the relative path change relink issues that LabVIEW struggles so tediously with.
The other question was from Eric, and he says, have you been able to completely eliminate VIPM from your workflow?
Yes, except for, and you know, there are things that, the interesting thing about the toolchain that we've built up is that we can arbitrarily take any folder of code, check it into our private Git repository, and then consume it just the same exact way that we consume our externals. And that's what we're having to do with our G package called Test Executive. For some mysterious reason, G Package Manager, despite it being searchable, says that it can't be found when we try to install it. For now, one of our workarounds is just check that into our just point our tool for installing Git submodules to that Git repository instead of the G package repository, and let it run and install that. So it's flexible. There's one VI package I can think of that I use right now, and it is VI tester. But that's a development dependency, not a runtime project source code dependency. right? So you can run all my code and build my executable without having VI tester. So for environment tooling, I have no gripe whatsoever with VI tester, and in fact, I'm sorry, with VI package manager. And I think it's one of the right tools for the job, because VI tester is a tool. It is specific to LabVIEW, and it is shared across all projects without being a dependency of those projects. Pretty heavy, deep dive into some dependency management nerdery. If anyone is interested in, forms questions more coherently after processing this content, I think Compose Systems would love to hear your thoughts and talk to you about how you solve these problems and what you like and don't like about dependency management. This is something members of our team have just grown passionate about, because we'd rather be writing solid software and not dealing with linking issues in the IDE.
Yeah, there's one more question from John Medlin, which is there any way to manage having two modules in the project which require different versions of common submodule? I'm assuming that you wouldn't put the version name on a .vi.lib file.
Okay, so the version name's not part of the namespace. If you are following semantic versioning and those two things that depend on different versions of a submodule depend on semantically equivalent versions, then that's not a problem, right? If it's a minor version difference, then they can mutually depend on the most recent minor version that satisfies both. If they both depend on different major versions, that is an irreconcilable dependency problem made clear by that major version change. And the only way to solve it is to actually solve it, right? So you'd have to rework probably the one that depended on the old version to fix whatever breaking changes were accrued when you updated the submodule to the new major version. Right. Semantic versioning tells us what we can do without getting in trouble, and it tells us when we're going to get in trouble, and that scenario is, oops, we're in trouble. So we just have to solve the trouble.
Okay, there's one last question. I think we are running a little bit late. So how do you go about pulling things out of .lib when they're designed to go there? And that's from Chris Stryker.
I'm going to give you an answer that's not going to be very satisfying, which is that we don't really use anything that is supposed to live in vi.lib that isn't a tool. So we solve that problem by omission. I don't see why you could not. Yeah, like if I think of anything, like, I have and I do use another VI package, NI's Modbus, like low-level Modbus driver. The product of NI R&D, that's not part of the DSC module. Like that's just a free VI package. That lives in vi.lib. If I wanted it to not live there, I could just throw it into a private repository and treat it like anything else. And when I put it there, it should be able to find all of its vi.lib dependencies because they're there. They're just not where it expected them to be. And any recompile process that prioritizes things found in vi.lib and things found under my project should be able to resolve that dependency issue.
Okay, that's great. Thanks a lot, Ethan. Appreciate for that presentation. That was really interesting. And anybody else, if you have more questions, please feel free to email it to us, or I think the chat would still be going on. So if you can pick it up, Ethan, that would be great.
Yeah, sounds good. Yeah, you can also email me at ethen.stern@composed.io.
Okay, you can post it on the chat maybe.
Yeah, cool. All right, well, thanks for listening, and I will stick around for a bit.
Yeah, thanks, Ethen.